Okay, we're going to go ahead and take a look at roots. The nth root of x means what number multiplied by itself n times would give you x. That little number n in front is referred to as your index. So here we have the fifth root of 0. So what number multiplied by itself 5 times would give you 0? Well, that is 0. So here we have the fourth root of 16. So what number multiplied by itself 4 times gives you 16? Well, that would just be a normal 2. Here, this is the cube root of 27, which means what number multiplied by itself 3 times is 27, and that answer is 3. Here we have the cube root of negative 8, which means what number multiplied by itself 3 times gives you negative 8, and that would be a negative 2, because the negative 2 times the negative 2 is positive 4, times the third negative 2 is negative 8. Down below here, what number multiplied by itself 4 times is negative 16? Well, if it was a positive 2 and multiply it 4 times, you get a positive 4. If it was a negative 2 multiplied by itself 4 times, you get a positive also. So there is no real answer. There's an answer, but we're not going to get to it yet. So for the most part now, if you have a negative inside of an even root, it's no real answer. So here we have the square root. You want to try to rewrite the inside as perfect squares to help you with your square root. Well, 16 is a 4 squared. X to the 6 is an x squared, another x squared, and a third x squared. Now, if you have perfect squares like this inside of a square root, your square root cancels out all these exponents of squaring, leaving you only with a 4, an x, and another x. Well, x times x times x is really an x cubed. Now that's one way you could have done it. You could have used fractional exponents and worked it out like that down here. We're going to be getting more into fractional exponents in this chapter. So if you're familiar with that, you can use this method. But what we talked about up here will always work. So on this problem, we're still going to have that negative in front. We have a square root, so I want to rewrite the inside as something squared. Right now I have it as something to the 4th power. So I'm going to write it as that something squared. And well, then I'd have that same thing squared a second time. So now I'll still have my negative. This square root's going to cancel out this squaring, leaving me with what's in front of the squaring. Same idea here. The square root black one's going to cancel out my squaring, leaving me with a q cubed plus 5. Well, a q cubed plus 5 times a q cubed plus 5 we could write as a q cubed plus 5 all squared. So here we have a 5th root. Well, a 5th root, we want to try to get all the insides to be 5th powers. So 243 is really a 3 to the 5th. A to the 10th would be an a to the 5th times another a to the 5th. A b to the 15th would be a b to the 5th times another b to the 5th times a third b to the 5th. Now, any of these 5th powers will be canceled out by this 5th root. So that's going to leave us with just the 3, the a, the second a, the b, the second b, and the third b. In other words, a times a you would write as an a squared, and b times b times b you'd write as b cubed. So over here we have a negative inside of an even root, a square root, and so that's no real answer. If it was a negative in front of an odd root, like a third root or a 5th root or a 7th root, well, we could get answers, and you saw that on that first slide. So go ahead and try to work these out and then watch the video. Try to rewrite the inside of this one in perfect squares. And then your square root cancels out each one of these squares. And then your x times x times x times x, you could write as an x to the 4th. Over here, we'd have a negative Try to rewrite the inside as something squared because we're dealing with a square root. Well, it would be an a cubed plus 2 squared, another a cubed plus 2 squared, and a third a cubed plus 2 squared. Now your purple square root will cancel out each one of these squaring exponents, leaving you just with those parentheses, still with that negative in front. All these parentheses are the same, so you could write it as one parenthesis all cubed, still with the negative in front. Here we have a negative inside of a square root, so that does not work. Try to also do this one here quickly off the top of your head. Rewriting the inside as something to the 5th power, so we'd have a 2 to the 5th for our 32, an x to the 5th is already something to the 5th. Our y to the 10th would be a y to the 5th, and another y to the 5th. Now, your 5th power, or 5th root here, cancels out all your 5th powers, leaving you just a 2, an x, a y, and a y, or a 2xy. So on this one here, you might think your answer is just t. Well, yes and no. So take a look down below here. If I have negative 2 to the 6th, if I have 2 to the 6th inside my 6th root, I do get 2. But if it's a negative 2 raised to the 6th, I get a positive 2. Because if you work out the inside here, a negative 2 multiplied by itself 6 times ends up being positive. And then you can take the even root of a positive number. And when you take an even root of a positive number, you get out a positive number. Over here, the 4th root of 5 to the 4th is 5. Or the 4th root of a negative 5 to the 4th is also positive 5, because if you work this bottom one out, a negative 5 multiplied by itself 4 times would be positive, and then you can do the 4th root of a positive number. So in other words, with an even root, you're always going to be getting out a positive. So to ensure that we're getting out a positive, we have to use absolute value. So on this one over here, we want to rewrite the inside as something to the 5th power because we have a 5th root. Well, we have a 3 to the 5th. This would be an x plus 2 to the 5th, another x plus 2 to the 5th, which would only be x plus 2 to the 10th, so we need a third x plus 2 to the 5th. Then your 5th root will cancel out each one of these 5th powers, leaving you with just a 3, an x plus 2 from this, an x plus 2 from the middle one, and an x plus 2 from the last one. So we could write that as an x plus 2 all to the 3rd power. So with that in mind, try to quickly do these two and then watch. Here, your 4th root cancels out your 4th power, leaving you with an x, but because it's an even root, we need to make sure that that is positive, so we have absolute value. Here, write the inside as something cubed, so that we get a 3 cubed. Write this as an x plus 2 cubed. We need a second x plus 2 cubed, which would be an x plus 2 to the 6th. We need then a third x plus 2 cubed. Then your cube root will cancel out each one of these cubing powers, leaving us with this. And then we could go ahead and simplify this by going x plus 2 to the 3rd power with that 3 in front.